Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to see a problem from partial differential equations. So let's get going. Problem: form partial differential equation by eliminating the arbitrary function from Lx plus my plus nz equal to f of x square plus y square plus z square. So we are asked to form a partial differential equation by eliminating this f from this equation. Let's begin. Given Lx plus my plus nz equal to f of x square plus y square plus z square, considered as some equation number 1. Now let's partially differentiate it with respect to x and also with y. Now I'll partially differentiate it with x. Partially differentiating one with respect to x. Okay. I'll apply dou by dou x on both sides of 1. You can do it directly. This gives us, here we are partially differentiating with respect to x, so we'll treat y as constant, and here z is a dependent variable and x and y are independent variables. We can write this as dou by dou x of first term, dou by dou x of second term, plus dou by dou x of third term equal to partial derivative of f of x square plus y square plus z square is f dash of x square plus y square plus z square into inner derivative, that is partial derivative of x square plus y square plus z square. Right? Which gives us, here L is constant, we can write it as L into dou by dou x of x plus partial derivative for constant with respect to x is 0, plus here we will write this as constant n into dou by dou x of z equal to f dash of x square plus y square plus z square into partial derivative of x square with respect to x plus partial derivative of y square plus partial derivative of z square. This gives us L into partial derivative of x with respect to x is 1 plus n into partial derivative of z with respect to x, dou z by dou x equal to f dash of x square plus y square plus z square into partial derivative of x square with respect to x is 2x plus partial derivative for constant with respect to x is 0 plus partial derivative of z square with respect to x is 2z into dou z by dou x. Since dou z by dou x equal to p, we have a notation. So we'll replace dou z by dou x equal to p. This gives us L into 1 L plus n into, replace it by p, equal to f dash of x square plus y square plus z square into 2x plus 2z, replace it by p, you'll get 2z p, right? Fine. Again, we'll write this as L plus np equal to f dash of x square plus y square plus z square into, take 2 common from these two terms, you'll get 2 into x plus zp. or we can write this as L plus NP equal to 2 times x plus zp into f dash of x square plus y square plus z square. Consider it as equation number 2. Now let's partially differentiate 1 with respect to y. Partially differentiating 1 with respect to y. Let's apply dou by dou y on both sides of 1. Here we are partially differentiating with respect to y, so we'll treat x as constant. We'll get dou by dou y of first term plus dou by dou y of second term plus dou by dou y of third term equal to partial derivative of f of x square plus y square plus z square is f dash of x square plus y square plus z square into partial derivative of, inner derivative, x square plus y square plus z square. Okay, this gives us partial derivative of a constant with respect to y is 0 plus here m is constant. We'll write this step as, this term as m into partial derivative of y with respect to y plus here n is constant. We'll write it as n into partial derivative of z with respect to y equal to f dash of x square plus y square plus z square into partial derivative of x square plus partial derivative of y square plus partial derivative of z square. This gives us m into partial derivative of y with respect to y is 1 plus n into partial derivative of z with respect to y, dou z by dou y equal to f dash of x square plus y square plus z square into partial derivative of constant with respect to y is 0 plus partial derivative of y square with respect to y is 2y plus partial derivative of z square with respect to y is 2z into dou z by dou y. Since we have a notation dou z by dou y equal to q, let's replace dou z by dou y by q. Then we'll get m into 1 m plus n into dou z by dou y. Q equal to f dash of x square plus y square plus z square into 2y plus 2z into q. Now take 2 common from these two terms. We'll get 2 times y plus zq, or we can write this same equation as m plus nq equal to 2 times y plus zq into f dash of x square plus y square plus z square. Consider it as equation number 3. Now observe equation 2 and equation 3. We have L plus NP equal to 2 times x plus zp into f dash of x square plus y square plus z square, and m plus nq equal to 2 times y plus zq into f dash of x square plus y square plus z square. Now what we'll do is we'll just eliminate f dash of x square plus y square plus z square from equation 2 and 3. By using 2 by 3, this term by this term equal to RHS part of 2 by RHS part of 3. Now we can cancel this 2 and f dash of x square plus y square plus z square. We'll just eliminate it, right? This gives us L plus NP by M plus NQ equal to x plus ZP by y plus ZQ. Now make a cross multiplication. L plus NP into y plus ZQ equal to x plus ZP into M plus NQ, right? Which gives us L into y, L into ZQ NP into y, NP into ZQ x into M, x into NQ, ZP into M, ZP into NQ, right? So you are having Zn PQ, Zn PQ in LHS and RHS, right? You can cancel these two. Now we'll get Ly plus ZLQ plus NPY equal to XM XNQ plus ZPN, right? Now bring these two terms to LHS, take this term to RHS, you'll get Ly. I'll write this Ly as YL. Okay, fine. Now take Q common from these two terms and P common from these two terms. Okay, I'll write the terms involving Q first. Now I'll write the terms involving P. Right. Now let's take Q common from these two terms and P common from these two terms. We'll get Q times ZL minus XN or NX plus P times NY minus ZM equal to XM minus YL. Or we can write this as Q into LZ minus NX plus P into NY minus MZ equal to MX minus LY, or P into, first I'll write the term involving P, now I'll write the term involving Q equal to MX minus Ly, which is the required partial differential equation. This completes the problem. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.